Hi guys, so for today's video, we're going to solve a problem regarding life cycle product costing. So this is in connection with one of our lessons entitled Pricing Decision and Cost Management. And yes, without further ado, let's get started. Gadzooks Inc. develops and manufactures toys that it then sells through infomercials. Currently, the company is designing a toy robot that it intends to begin manufacturing and marketing next year. Because of the rapidly changing nature of the toy industry, Gadzooks management projects that the robot will be produced and sold for only 3 years. At the end of the product's life cycle, Gadzooks plan to sell the rights to the robot to an overseas company for $250,000. Cost information concerning the robot follows. So this is the information table presented in the problem. For year 1, for the design costs, we have a fixed cost of $650,000 and no variable cost during the year. For years 2 to 4, for production costs, we have $3,560,000 fixed cost and $20 per unit of variable cost. For marketing and distribution costs, we have $2,225,000 fixed cost and $5 per unit of variable cost. Here, it is stated that the fixed costs allocated are for 4 years already. The problem lastly states that for simplicity, we are going to ignore the time value of money. For the requirements, the first one states, suppose the managers at Gadzooks price the robot at $50 per unit. How many units do they need to sell to break even? So first, we have to compute the total variable cost per unit. And as what was shown on our table a while ago, production cost per unit is $20 and $5 for marketing and distribution cost. By adding the two, we will come up with the $25 variable cost per unit. The next is the computation for the total fixed costs over the life of the product. Here, we just have to add the amounts given on the table under the column of fixed costs. So, $650,000 plus $3,560,000 plus $2,225,000 leads to a total fixed cost of $6,435,000. Now next is the contribution margin per unit, which will be one of the keys into getting the break-even point in units that we are looking for. So here, we just have to minus the selling price of $50 per unit to the variable cost per unit of $25. Now, upon getting both the total fixed costs and contribution margin per unit, we will be able to compute for the break-even point in units. By dividing $6,435,000 to 25, we will be given a $257,400 break-even point. Now for the second, which is also the last requirement, we have here the managers at Gadzooks are thinking of two alternative pricing strategies. The first one states that they will sell the robot at $50 each from the outset. At this price, they expect to sell 500,000 units over its life cycle. The computation for this would be the total revenue less its costs, which includes both variable and fixed costs. Now for revenues, we simply multiply $50 to 500,000 units, and so this will amount to $25 million. For variable costs, we have $12,500,000, which was computed by multiplying $25 to 500,000 units. As for our fixed costs, it will be $6,435,000. Again, the fixed cost is the one we have computed before. Now, as we lessen the revenue with the costs acquired, the operating income would result in $6,065,000. Lastly, for the second and last option for pricing strategies, boost the selling price of the robot in year 2 when it first comes out to $70 per unit. At this price, they expect to sell 100,000 units in year 2. In years 3 and 4, drop the price to $40 per unit. The managers expect to sell 300,000 units each year in years 3 and 4. Which pricing strategy would you recommend? Explain. Shown here is the computation for this option, wherein we considered the revenues gained throughout the years or the product's life cycle. Considering the difference in its selling price and units sold, we have come up with $70 million gain on year 2 and $24 million for years 3 and 4. With a total of $31 million, we deduct both variable and fixed costs of $17,500,000 and $6,435,000 respectively. Now for this option, we have a total of $7,065,000 of operating income, which is bigger than option A by $1 million. Because of this, the pricing strategy presented in letter B is the better option for Gadzooks. Unlike the strategy used in letter A, B considered changes in its selling price, which mainly leads to the movement of the units sold. This then led to the increase in its operating income compared to that of in letter A, taking into consideration the demand during those years.
And yes, that will be all for this video. I hope you learned something. Bye!